So we're doing some Cal 1, and we're talking about antiderivatives and indefinite integration, and so that's basically what we're going to be doing here is some indefinite integration. Anyway, I've got some problems here written out that we're going to solve. We're going to find the indefinite integral of the following. So you notice it doesn't say y is equal to. I just kind of left that part off. And we're just kind of focusing on this piece here. So here's three problems that we're going to work. So maybe you should try writing those down and working this stuff out maybe before I do and see what you get. All right. Okay. So for the first one, we are finding the indefinite integral of x plus 1 dx. So this is equal to. So we add 1 to the exponent. And remember, we take the exponent, put it down into the denominator, plus, and of course we have a 1 here, so we're going to add an x. Now think of it this way. If you took the derivative of x, what do you get? You get 1, right? And if you take the derivative of x squared over 2, you should get back x. So remember what this is, what that is called right there. That's called the integrand. And remember, if you leave off this c right here, this problem is wrong. Okay? So we always want to write the general solution. All right, the next one we have x squared plus 1. So we're taking our time learning this stuff real slow. We have x raised to the second power. So we're going to add 1 to the exponent. That gives us a 3. And of course it's over 3. And then of course we take the integral of 1 and we get back x plus c. So remember, you take the derivative of this and you should get back x squared plus 1. So that's the good thing about doing integration. You can always take the derivative and check your answer. Plus x dx. Alright, so we're going to have x to the 5th over 5 plus, and then of course this is going to be x, remember, add 1 to the exponent, over 2, and then plus c. It's that simple. And you know something? We got lots of time. Let's work some more. Let's say we had the integral of, let's say, x to the half minus 3x, let's say, and then plus 7 dx, and I'll just continue this down here. So we add 1 to the exponent, and of course adding 1 to the exponent is going to give us 1 over 1 is 3 2/3, or 3 halves. So you'll have to refreshen up on your fractions there, and take the 3 halves and put it in the denominator. And actually, if you're a business major, you probably are going to be refreshing up on your fractions. Add 1. I couldn't tell you how many business majors that took survey to calculus that I've tutored over the years, and getting those fractions back fresh in their mind was a struggle for a minute or two. Okay, and of course what are we going to do here? We're going to put the 2 up front and bring the 3 down here, right? So it's just the reciprocal, flip this thing around, and then minus 3x squared over 2 plus 7x plus c. But I promise you, by the time you leave Cal 1, if you survive, you should get that stuff down. Okay, what about this one? Well, a lot of times we have to rewrite it, and so this becomes x to the negative a half dx, and then we go from there, right? Taking the or adding 1 to the exponent and so forth. I'll let you work that one out. Hopefully you can get that worked out there and get the answer. Remember,